Hi viewers, welcome to LMS Solution. Today we are going to be see about MATLAB simulation of standalone PV system with battery and the grid connected PV system with battery. That means the both system will be operated. That means the both will be simulated in the same simulating model. Then we are going to create some logic between standalone operation and the grid connected mode. The standalone we can call it as condition. Whenever there is no grid power or grid is disconnected from the system, then the PV system, the battery should be operated as a standalone in order to supply AC load as well as DC load. So whenever the grid available, then it going to be connected to the PV system, the battery. Based upon PV system parameter, that means PV current or power or battery SOC, we are going to decide whether we are going to send the power to the grid or we are going to get the power from the grid to supply the AC load as well as DC load. For that, already we developed the model both the standalone PV system with the battery and grid connected DC battery in the MATLAB simulation. Today I'm going to explain the operation of these both condition in the MATLAB. For that, I'm going to open that the simulation model. So this is a model created for a standalone or islanded mode operation of solar PV with the battery system. Grid connected mode operation of solar PV with the battery system. Here you can see that the system consists of PV panel and then boost converter, and then it's going to be connected with the DC bus, and also here we have a DC load, and we have battery, and then bidirectional DC converter. It will be connected with the DC bus, and then here you can see that this is single phase inverter is connected to the DC bus, and here we have the filter, self filter, and then here we have AC load, then here we have grid supply. And the PV panel is controlled by means of incremental conductance MPPT. So this incremental conductance MPPT is implemented here for his solar PV system to extract the maximum power from the PV panel. And then this bidirectional DC-DC converter, the voltage, that means output voltage of this bidirectional converter is controlled by means of voltage controller. Here we used PA controller to maintain the DC bus voltage at 400 volt. And then this inverter can be operated in bidirection when is connected with the grid system. Here the inverter having two kind of control logic. One is this inverter can be controlled in the grid connected mode, and then this inverter can be controlled by means of standalone mode operation. Here you can see that this is the control logic for the grid connected mode operation inverter control. And then here you can see here this is island and mode operation of this of the inverter. This is a control algorithm used for island and mode. And here we created some event. I mean, here we have controlled voltage source. It's going to be controlled by means of this two block. That means sinusoidal waveform is multiplied with some constant. If constant I'm going to put 0 means the output will be 0. That means the system will be goes to islanded mode or a standalone mode. When I'm going to put the constant equal to 1, then system going to be active connected mode. The same control logic is given to this circuit breaker. So the circuit breaker going to be open based upon the voltage of this control voltage source from this thing. This constant 0, then system will be disconnected from the solar PV battery inverter system. Then it will be operated standalone. When the constant equal to 1, then it will be, that means the breaker will be closed, and then this source will be going to be connected to the solar PV battery inverter. Then it going to be operated in the connected mode. This, that means the control logic about the control logic, incremental conductors, and then voltage controller for that bidirectional converter and grid connected mode operations. Already we explained in that normally that grid connected solar PV with the battery system. Now I am going to explain islanded mode operation. That means when the system is not connected, we need to apply the islanded mode conditions based upon that load voltage and then load current. We need to control this inverter. For that, I'm going to explain the concept. Here you can see that we are going to measure the inverter voltage, and then it's going to be converted into AB to DQ form. And then here by using sinusoidal waveform, we are going to generate the sine cosine. Based upon this sine cosine value, we are going to generate the reference, D reference and Q reference. It going to be compared with the actual quantity of and D and Q, and then is going to be processed via voltage PA controller. Finally, we'll get the direct and coordinate axis control voltage here that will be converted into AB form. dq to abc. Then here we are going to take only a quantity only. That a quantity is going to be combined with the inverter current and then is processed via PA controller. This PA controller going to be generate the modulating based upon the islanded load condition. When the grid voltage is equal to 0, then it should be operated island. When grid voltage equal to that means that command equal to 1, then it going to be operated in the grid connected mode. For here we have that switch. We are comparing that value. When this value equal to 0, the condition is not true, then it going to be connected via here. This will be it taken from the islanded mode. This is the modulation index from the islanded mode operation. This modulating index going to be processed via the scheduling generator for generating the inverter. When the command is 1, the condition is true, that we connect this one. This one is come from here. The emailing the modulating signal from the step connected mode inverter control. That means where the grid is connected with system, we are going to take this modulating signal. When the grid is not disconnected from the system, we are going to take the modulating signal from the islanded mode control. Next time you will explain the system. Here you can see that we are measuring the grid voltage, current and power. Here you are measuring load voltage, current and power. And then this one used to for measuring the PV power. This one used to for measuring the DC bus voltage and current and power. This is battery measurement, and then this is inverter voltage, current and grid current. And then this one used to for measuring the SOC of the battery. Now I'm going to operate the mode in the island operation. That means the grid is disconnected from the system. So I'm going to simulate this model. Systems operate in grid connected mode. That's why you can see that the grid voltage is 0 and grid current 0. There is no power from the grid because it's operating in standalone condition. Here you can see that this is the PV power. Here you can see that I have taken the condition initially which is equal to 1500, 200, and then change to 500 and then 1000 for every 0.3 seconds. So you can see the results of the PV, battery, DC load, grid, and then AC load, and then SOC of the battery. Here you can see that the DC load at the AC load continuously getting the power right from that solar PV system and battery when it's operated in the island mode condition or standalone mode condition. Both system will be receiving the power. This is AC load and then this is DC load when it is operated in the standalone mode or the islanded mode operation. Now I'm going to change the system in the grid connected mode. That means I'm going to change the control logic. Here is 1. That means now systems operated in the grid connected mode. Now I'm going to simulate this model. Now we can see that grid is connected. That's why we are having AC voltage and current, and then with having some power. And then you can see that this is AC load, load voltage, load current, and load power. This is DC load, voltage, current, and power. And then this is the parameter of PV and the battery. This is SOC of the battery. In this condition also it's work. Now I'm going to simulate the model from changing over from grid connected mode to islanded mode condition. For that I'm going to use some step signal. Here I'm going to connect that step signal here. Initially the operator in grid connected mode. After some seconds, for example, I'm going to consider after 0.8 seconds, it will be operated in the islanded mode. So next I'm going to simulate this model. So up to 0.8 second system is operated in the grid connected mode. You can see the power from grid, and that means availability of grid here, right? And then here you can see that PV voltage, current and power, battery voltage, current, DC bus voltage, current and power, load voltage, AC load voltage, current and power, and then SOC of the battery. Here you can see that during the 0.8 second, now you can see that system is move on to islanded mode or a grid connected mode. There is no power from the grid, or there is no power into the grid. System is now operating in the islanded mode condition. There is no deviation in the load power. Load continuously getting power. During the changeover from grid connected mode to islanded mode, there is small deviation in the power, but after some seconds, this restored to the that same power level. Here you can see that this is switchover from this point, right? So from grid connected mode to islanded mode condition. Now I'm going to simulate the model from islanded mode to grid connected mode at time of 0.8 seconds. Now you can see that initially there is no voltage and current from the grid side, and then system will be operate on the main DC load and AC load using the power from the PV and battery only. After 0.8 seconds, you can see that it moved to grid connected mode. Now we can see that the system is changed from islanded mode to grid connected during that 0.8 seconds. Our system is under grid connected mode operation. For this condition also, the system will be work fine. The load is in power of the VV battery and also grid. Here that during grid connected mode based upon SOC, right? Here we create a condition, right? Based upon PV current and SOC, the power will be sent to the grid and we see the power from the grid. This logic already we explain in the my early video like grid connected solar PV with battery system. So you can check that video. This is working of grid connected and island mode operation of solar PV with battery system. Grid connected and standalone mode operation of the solar PV with the battery energy storage system. Thank you for watching the videos. Kindly subscribe our channel and also click bell icon for notification about upcoming videos. Thank you so much.